All right, so let me go up here and I got to turn that on. That's what my problem was before. Click, copy, paste. There we go. Now let's kind of make this look like a 30, 60, 90. And we'll make it a little bit bigger. Oops, I don't want to do that. There we go. That's kind of cool, huh? All right. Right triangle. And this obviously would be the 30 degree, don't you think? 60. Up here. All right. Now, both of these sides are not the same. On that other triangle, we put, little marker things there, little tick marks there to show that they're equal to each other. These are obviously not equal to each other. This is still the hypotenuse. What do we call this? Do you remember from last year? In geometry, we refer to this side as the what side and this side as the what side? Short side and long side. Very good. Okay. So this is the short side. And I want to see what they do in the book. Okay, they make the short side x. I won't write short on there. I'll just put that on there. Now, there's a relationship. And they all had to do with the short side. I'm going to write it down. This may be familiar to you. Let's do the hypotenuse first. The hypotenuse was the easy one. The hypotenuse was equal to what? They all referred to the short side. How much? 2, right. It's 2 times the short side. So it would be 2x, right? So it's twice the short side. And the longer side, we'll just put long, but it's the longer. It's not the longest, right? Because the hypotenuse is the longest. So the longer side is, what was the number for that? Square root of, well, 45 was square root of 2. This one is square root of 3, okay? I don't know. You can kind of remember. I kind of gave you an idea. 2 is the same thing as square root of 4, right? The longer side is just a little bit smaller than the square root of 4, which is what? Square root of 3. Or you can remember it this way. This triangle right here has a 3 in it for the 30, so you can remember square root of 3. I don't know if that helps or not. Whatever way works for you. So it's the square root of 3 what? Times the short side. That's right. So let's mark these right on the triangle itself. So this would be 2x, and this would be a square root of 3x. Now again, I didn't go through the whole process on why that's true. We did that in geometry. We're not going to do that right here. All right, so what do we want to do? We want to do that sine, cosine, tangent thing, didn't we? So let's do it. Now, we have 2 different angles. Before, we only had 1, right, because both angles were both 45. So this one, we're going to do sine, cosine, tangent of 30, and we're also going to do what? Sine, cosine, and tangent of 60. Good. Okay, so we're going to do sine of 30, and I'll just write them all down, then we'll fill it in. Cosine of 30, tangent of 30. All right. All right, you know what we're going to do now, don't you? Here's the 30. We're going to do the sine of 30. So the sine, again, is opposite over hypotenuse. Opposite is x. Hypotenuse is 2x. So it's x over 2x. What does that reduce down to? 2. Not 2. It's 1 over 2. So it's 1/2. Now, 1/2 is not a hard number to remember. But remember I said square root of 2 over 2, something you're going to have to memorize for the cosine and sine of 45. This is another one you need to memorize, is 1/2. All right? It's not a hard number. But it's one that's going to show up a lot. Let's do the cosine of 30. Cosine would be the adjacent over the hypotenuse. So it's the square root of 3x over 2x. That one's easy. X's cancel out. What do you get? Square root of 3 over 2. Good. All right. That's another one. So what do we have before? We had square root of 2 over 2 on a 45/90, and on a 30/60/90 we have square root of 3 over 2. You got to keep those straight, all right? And I don't know how you can do that. I don't really have any special tricks or anything. You just have to remember it, all right? The square root of 3 over 2. You could always go to this if you wanted to, couldn't you, if you forgot what they were? All right, it's up to you. But, I mean, it's nice to memorize these things. I think that's really helpful. All right, tangent of 30. So the tangent is opposite over adjacent. This is another one that we want to memorize. So it's opposite, which is x, over the adjacent, which is square root of 3x. And then the x's cancel. It's a 1 on the top. So again, this is going to be what? Square root of 3 over what? 3. Good. That's another one you want to memorize. Seems like there's a lot of memorization, but the more you do this, the quicker it'll come. I'll give you a little hints as we move on. I think they're really just introducing this to you right now. They're not going to get really heavy duty into it, but we will see it later in another lesson. I don't even know if it's this chapter or the next chapter, but we will definitely do a whole bunch of this a little bit later on. Okay? Now we did 30 degrees. Let's do 60 degrees. So let's do the sine of 60, the cosine of 60, and you're going to definitely see some relationships between these. remember yesterday we talked about that? We talked about the sine of an angle and the cosine of its complement. What was it? So the sine of 60, without doing any math, tell me, Brandon, what would it be? The sine of 60 would be the same thing as what? Well, the cosine of 30, which is square root of 3 over 2, right? Do you see that? All right, let's see if it is. Let's just look at our triangle, look at the relationships, and see if it really does work that way. So the sine of 60 is opposite over hypotenuse, so it's the square root of 3x over 2x. That's the same exact thing as that, isn't it? I don't have to go through all that mess again, so I'm just going to write square root of 3 over 2. All right, cosine of 60. Now the cosine is adjacent over hypotenuse, the same thing as what? The sine of 30. Do you see that? All right, so what did that come out to be? Just 1/2. All right, and the tangent of 60. This is a new number. Okay, this is, now remember, the two tangents were what to each other? Give me a good word. Yeah, inverse. Okay, the inverse of each other. So let's not look at this. Let's look at this one. The tangent of 30 is 1 over the square root of 3. So what do you think the tangent of 60 is going to be? Just a square root of 3 over 1, right? Or just square root of 3. Make sense? Let's just look at it up here, and let's do that tangent. Go opposite over adjacent. So this is opposite, this is adjacent, and you see it works out real nice. Without just believing or just remembering that they're inverses of each other, we can actually do the opposite over adjacent on this triangle. What's that? Do a proof? Is that what you said? Not today. All right, so there you go. These are things you need to remember. Again, you're walking down the hall, somebody taps you on the shoulder and asks you what the cosine of 60 is. All right? It's something to remember. Now, later on, I believe this is the next chapter. Later on, we are going to see relationships with this, but we're actually going to see a relationship with a circle. And you say, well, how does a circle have anything to do with any of this stuff right here? It does. All right? You think, well, that's a triangle. How in the world do we bring circles into this? I think that's the next chapter. Again, I don't have, it's a new book this year for us, so I believe it's the next chapter, but we'll do that when we get there. All right, let's see. Am I leaving anything out? Flip through here. Well, they have some word problems, but the word problems pretty much cover what we did before. You want to do one of those? Oh, angle of elevation, angle of depression. You hate those?
We're not doing like secant.
No, we're not going to do that today. Well, let me do that real quick. 7 minutes? All right, I got time. I got like 3 minutes, right? Let's do this. The sine is the opposite over the hypotenuse. Now, the inverse of this would be the hypotenuse over the opposite, and they give a word for it. Okay, this is the sine. S-I-N-E is how you spell sine, but we shorten it up to this. The inverse of the sine is a thing called the cosecant. Now, we don't write that whole thing out. We write it like this. So, what's the cosecant of an angle equal to? Not the opposite over the hypotenuse. It's the hypotenuse over the opposite. All right, let's do the cosine. Cosine is adjacent over hypotenuse. The inverse of the cosine is the secant. And we just shorthand that, S-E-C. All right, and instead of adjacent over hypotenuse, obviously it's what? Hypotenuse over that. And then we had tangent. Tangent was opposite over hypotenuse. I lied. It's opposite over adjacent. All right, and it's the inverse of the cosine, okay, and the cosecant is the inverse of the sine, okay, because we took the reciprocal, right, of those. So the this would be cotangent, cotangent, and COT, obviously, or maybe not obviously, I don't know. Oh, daggone it. Now let's do this. Let's just bang, bang, bang. I'm not even going to edit this. I'll keep the daggone it on. Because Khan Academy, all his little flubs on there, he keeps in there. So I figure if that's good enough for him, I can deal with it. All right, so there you go. So it's the cosecant, secant, cotangent. You'll see those a little bit. I think they, on this chapter and this lesson, they just kind of introduced it just so you could see it. I don't think they're really going to use that too much. When you get into the next chapter, we're going to be doing a lot heavier trig stuff. You'll see it there. Okay? All right. I'm running out of time. Let's stop this one, and then I'll go to one more, and we'll do like one example, maybe two. I think we have about 4 minutes left.